Probability is the study of randomness, like the flip of a gold coin spinning through the air. Every possible outcome forms a sample space, represented here by these points. An event is a specific collection of outcomes, like this group called Event A. To calculate probability, we divide the number of successes by the total sample size. We measure these chances on a line from 0 to 1. 0 represents an impossible event, while 1 represents something that is absolutely certain. Exactly in the middle, we find a 50-50 or even chance. When multiple events like A and B overlap, we call them joint events, highlighting where they intersect. This is the logic of chance, the mathematical framework for understanding our unpredictable world.
Let us explore central tendency using a simple number line. Imagine these dots represent data points spread across our scale. First is the mean. It acts like a balance point where the values find equilibrium. Next, we look at the median. By lining everything up in order, we find the value in the exact middle. Then we find the mode. This is simply the value that appears most frequently in our set.
These three measures together help us identify exactly where our data is most concentrated.
Each one helps us find the data center to better understand the numbers. Let us explore the concepts of variability and spread, starting with a central value called the mean. When our data points are clustered closely around this center, we call it low variability. However, when data points are spaced far apart, we see high variability. The range shows us the total distance between the extreme values in the set. Beyond the range, we can measure the specific distance each individual data point sits from the central mean. If we transform these points into a smooth bell curve, we can use standard deviation denoted by the symbol sigma to quantify the typical spread of our data. In the end, understanding spread is all about recognizing data consistency. Welcome to our look at the normal distribution. This curve is known as the bell curve. The peak marks the average, known as the mean. We change the spread using the standard deviation. A high sigma widens the curve, while a low sigma narrows it. Within one standard deviation, we find 68% of all our data. Expanding further, we capture 95% of the data. Watch individual points fall into place. They naturally cluster at the center to form this universal shape.
This pattern appears everywhere in our world, from nature to human behavior.